Assalamualaikum and a very good day everyone. So my name is Wanur Adiba binti Wani Samudin, MA 19080. So we are from group 2 for subject BMM 3521, and we are going to talk about our fourth experiment, which is series parallel pump. For my part, I will share with you about our introduction for this fourth experiment, which is experiment series and parallel pump. First, for the parts of background, so to sum up our background in our report, so we can conclude that the pumps are used in the processing of oils, chemicals and combinations of liquid and solids. They are often used in conjunction with one another to boost flow or pressure beyond what can be achieved by a single pump working alone. They also have two main configurations for pumps, which is parallel and series pump. Next is for our problem statement. So in our problem statement, it states that the centrifugal pump is powered by an electric motor, which as shown by the tachometer, and may be adjusted to operate at any end speed that the user specifies. The water tank is delivered to the tank through a flow control valve and either a venturi or a counterport inside the tank itself, and the water is drawn from a storage tank, and changing the setting on the flow control valve will affect the resistance of the system, and as a result, the operating point on the head characteristic of the pump will vary as well. Then the piezometers are secured to the pipes close to the pumps, which is in intake and outflow, in order for a differential manometer or a manometer to accurately measure the total manometric head. Using the flow meter, another measurement of the differential height is carried out, and the flow rate Q is derived from the calibration of the meter, which measures how much water is flowing through the flow meter. Next, for our objective is to show the fundamental working characteristics of a centrifugal pump when it is functioning in series, parallel, or as a single pump. And we also want to calculate the pump characteristic curve of the pump, whether it is configured in series and parallel, as well as when it is operating individually. And last but not least, we want to establish the pump's horsepower. Okay, so for the scope of our experiment, so in this experiment, the individual pump as well as the parallel and series pumps are determined, calculated and analyzed. So for this experiment also, we will employ pump devices and in series and parallel configuration. And for each experiment and given setup, there are several more components such as the control valve, a valve, flow, sensor, and so on. Also, in this experiment, a pump performance curve may be generated by connecting the head of two or more pumps in series to the same flow rate. For the same flow rate, the delivery head will be twice as high if two identical pumps were linked in series. So speed as observed at the second point and the point 3 on the system curve is effectively shifted in that direction by the combined head and flow velocities. So that's all from me for the introduction part, and I will pass it to our next member for the next part. Thank you.
Assalamualaikum and a very good day. My name is Nina Rashikin binti Rajudullah, MA 19107. So for this lab, I'm going to present the theory of the report. So for series and parallel theory, there are two types of connection for pumps, which are pumps that can be arranged in parallel and series in order to provide the head or flow rate capacity. The delivered volumetric flow is dependent on the pressure, which the pump has to generate within the pipe network. When the pressure is high, the resulting volumetric flow will be low. And also when the pressure is low, the volumetric flow will be high. That's the theory of this report. The resulting pump performance curve can be obtained when two or more pumps are arranged in series and parallel. So for series pumps, point 2 indicates that when two identical pumps are in series, the head will be double of the head of a single pump at the same flow rate. Within the constant flow rate, the combined head moves from point 1 to point 2 and along the system curve to point 3. When two pumps with equal performance curve run in series, the head is equal to half of the head at the point 3 and flow rate is equal to the flow at point 3 for each pump connected in series. So sum of pressure total is equals to sum of pressure at point 1 plus pressure at point 2, and Q total is equal to Q1 is equal to Q2. Pump arranged in series by adding the head at the same flow rate as in figure. So for the parallel pump, the volumetric flows of the pumps are added together. The achievable pump pressure remains the same. For the two identical pumps connected in parallel, when the head is constant, the flow rate is calculated twice the single pump, which is double of the single pump. Note that when two parallel pumps with the same curve of performance, the head will be same with the head at point 3. Meanwhile, the flow will be half of the flow at point 3. So sum of P total is equals to sum of P1 equals to sum of P2. And the Q total is equals to Q1 plus Q2. So for the power, the resulting power for the resulting pump from volumetric Q and the achievable pressure difference between delivery and intake side we can calculate by using the formula power is equals to sum of the pressure times by Q. And the input power is usually electrical power, and the output power is dependent on the pump efficiency. So for the formula is equals to, so for the power input we can calculate omega T also 2 pi n over 60 times by T. That's all from me. Thank you.
Hello, my name is Nur Shafiqah binti Adira. My ID is MA19094. I would like to continue the presentation about the method and procedure of this laboratory. First one is apparatus. Number one, we have manual valve that make possible to switch quickly between series and parallel operation. Second, the manometers indicate the pressure at all important points in the pipe system. Third, the hydraulic power output of the pumps can be determined. 4, the water supply, and last one, 5, is volumetric flow rate. Next, we have experiment procedure. For the experiment 1, single pump operation. Number 1, connect the stopcocks. Second, handle parallel to the pipe which is valve closed. Third, handle perpendicular to the pipe which is valve open. Next is switch on pump 1 with the main switch on the switch box and pump 2 remains off. 5. Set the volumetric flow with the drain cock to ensure continuous with water inflow into the reservoir. 6. Record the measured valves. After that, P-suction on the intake side of the pump. 8 is P-delivery on the delivery side of the pump. Last one is vary the volumetric flow and repeat the previous measuring procedure. Next is experiment 2, series pump operation. Number 1, connect the stopcocks. Second, handle the parallel to the pipe which is valve closed. Next, handle the perpendicular to the pipe which is valve open. After that, switch on both pump 9 and 10 with the main switch on the switch box. Next, set the volumetric flow with the drain cock. Number 6, record the measured values. 7, P section 1 on the intake side of pump 1. Number 8. Delivery P1 on the delivery side of the pump 1. Next is P section 2 on the intake side of the pump 2 and P delivery 2 on the delivery side of the pump 2. Lastly, vary the volumetric flow and repeat the previous measuring procedure. Last one is the experiment 3, parallel pump operation. Number 1, connect to the stopcock. Second, handle the parallel to the pipe which is valve closed. Next, handle the perpendicular to the pipe which is valve open. Number 4, switch on both pumps with the main switch on the switch box. After that, set the volumetric flow with the drain cock to ensure continuous water inflow into the reservoir. Next, record the measured values. 7. P suction 1 on the intake side of pump 1. P delivery 1 on the side delivery of the pump 1. Number 9. P suction 2 on the intake side of the pump 2. Number 10. P delivery 2 on the side delivery of the pump 2. 11. P outflow at the outflow. Lastly, vary the volumetric flow and repeat the previous measuring procedure. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badrul Amin bin Razak and my metric number is MA19082. Okay, today I will present about result and discussion for 3 experiment. So let's go to experiment number 1, which is experiment for single pump operation. From the experiment, we get the data for volume flow rate and P suction and P delivery. From this data, P suction and P delivery, we can get the value for the P single, and then when we get the value for P single, we can calculate net head using the formula for net head, and also we can get the value for water horsepower using the formula water horsepower. Okay, when we get the result for net head and water horsepower, we need to plot the graph. So this is the graph for head against the volume flow rate for experiment number 1, which is single pump curve. Okay, next we go to the experiment number 2, which is series pump operation. We also get the data for volume flow rate and P suction 1, P delivery 1, P suction 2 and P delivery 2. Okay, so when we get the data from the experiment, we need to input the data from experiment into the formula to find net head and water horsepower. So when we get the value for net head and water horsepower, we just need to plot a graph just like experiment 1. So this is the graph for experiment number 2, series pump curve, which is head against volume flow rate, similar like the experiment number 1. Okay, next we go to the experiment number 3, experiment 4, parallel pump operation. Okay, from the experiment, we also get the data for volume flow rate, and we also get the data for P suction 1, P delivery 1, P suction 2 and P delivery 2. Okay, from the P suction and P delivery, we can get the value for net head by using the formula, and so we're using the formula to find value for water horsepower. Okay, next we need to plot graph for this table. Okay, let's go. So this is the graph for parallel pump operation. So same like other graph, head again, volume flow rate. So that's about table and graph. So we need we go to the sample calculation. So we need to assume that density of water roll equal to 1000 kg over m cube, and then gravity G equal to 8 and 9.81 m as negative 1, And for the formula for net head, H equal to rho G M. So for the formula for watt horsepower, rho GHQ. So this is the example for net head for single pump, which is P delivery minus P suction over rho G. So next, for series pump, P delivery 2 plus P delivery over rho G. And for parallel pump, P lowest delivery pressure over rho G. Okay, next, for calculation for watt horsepower, which is single pump, series pump, and parallel pump, using same formula, which is rho GHQ. So we can get the value. And next, go to the discussion. So we need to compare the experiment performance curve to its theoretical curve and discard the discrepancy factor. The parallel pump has the maximum flow rate, whereas the series pump has the highest rate. According to the experiment practical curve diverge greatly from the theoretical curve due to the pipe loss. Okay, B. From the result obtained, state the use of series and parallel pump. The output of series pump should be double that of a single pump, resulting in effect on the system provide flow rate and clean head. So next, for C, explain why the system with series pump configuration will generate higher pressure than the parallel pump configuration. In a series pump setup, more power is required to overcome and high load, resulting in a high pressure head. The parallel pump, on the other hand, has a header structure that connects to pump and provide the same pressure and discharge interaction. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rosdella binti Ramli and my ID is MA19101. So today I was responsible to present the conclusion of this experiment. So for the conclusion, so based on data we obtained and we successfully and accepted the data. And so for the series and parallel, we can plot the characteristic pump curve by measuring head loss and flow rate Q. So in series connection or arrangement, each pump handle the same flow rate, but the total head loss produced by the combination of pump will be additive. So for pump configured in parallel, the flow rate Q is split between the pump at the inlet. So basically, the experimental result and the theoretical calculated value are almost similar within the experimental error and prove that the law of conservation of mass. So I think that's all from our group. Thank you.